Albert Einstein. The name is synonymous with genius. He's the epitome of scientific brilliance, a pop culture icon. With his wild hair and playful demeanor, he captured the world's imagination. Einstein's theories revolutionized our understanding of the universe. He unveiled the secrets of gravity and light, but perhaps his most mind-bending idea was his concept of time. Before Einstein, we saw time as a rigid, unchanging backdrop to our lives. It marched forward at a constant pace, never slowing down or speeding up. Einstein shattered this notion. He showed us that time is not absolute. Time, he revealed, is relative. Einstein's theories of relativity unveiled a universe stranger than we could have ever imagined. His groundbreaking ideas transformed our understanding of space and time. He showed us a universe where time is not a universal constant, but rather a variable that can change depending on various factors. Instead, time is woven into the very fabric of space-time, creating a complex and interconnected tapestry. It's a flexible, dynamic entity that can be stretched and squeezed. Imagine a giant trampoline. This trampoline represents space-time, a concept that is both fascinating and mind-bending. Now place a bowling ball in the center. This simple analogy helps us visualize the complex nature of space-time. The bowling ball is like a massive object, such as a star or a black hole, exerting its influence on the surrounding space. Notice how the trampoline curves around the ball. This curvature is a key aspect of Einstein's theory. That's how massive objects warp space-time, creating a gravitational field that affects everything around it. This warping of space-time affects time itself, causing it to slow down in the presence of strong gravitational fields. The stronger the gravity, the slower time flows, a phenomenon that has been confirmed by numerous experiments and observations. This mind-boggling concept is one of the cornerstones of Einstein's general theory of relativity, forever changing the way we perceive the universe. One of the most fascinating consequences of Einstein's theory of relativity is the concept of time dilation. It tells us that time passes at different rates depending on your relative motion and speed. The faster you travel through space, the slower you move through time. This means that high-speed travel can actually affect the passage of time. Imagine two identical clocks. One clock stays on Earth. We'll call this the stationary clock, which ticks away at a normal pace. The other clock travels into space at incredible speeds. This is our traveling clock, moving much faster than the stationary one. When the traveling clock returns to Earth after its high-speed journey, something amazing happens. It shows less time has passed compared to the stationary clock, illustrating the effects of time dilation. This isn't science fiction. It's a scientific fact that has been proven through rigorous experiments. Experiments with atomic clocks, which are incredibly precise, have confirmed the reality of time dilation. Time is not a rigid, universal metronome that ticks the same for everyone, everywhere. Instead, it's a fluid, relative phenomenon that changes based on speed and gravity. Section 4. Wormholes and time travel. A cosmic shortcut. Einstein's theories opened up the possibility of something truly extraordinary: time travel. His groundbreaking work on general relativity suggested that the fabric of space-time could be warped and twisted in ways we are only beginning to understand. Could we journey into the past or leap into the future? The concept has fascinated scientists and dreamers alike for generations. While the idea seems like science fiction, the mathematics of general relativity hint at intriguing possibilities. These equations suggest that under certain conditions, time travel might not be entirely out of reach. One such possibility is the existence of wormholes, theoretical passages through space-time that could create shortcuts for long journeys across the universe. Imagine folding a piece of paper in half. This simple analogy helps us visualize the concept. Now imagine a tiny tunnel connecting the two sides. This tunnel represents a wormhole. That's a wormhole, a shortcut through space-time, potentially allowing for faster-than-light travel. Theoretically, a wormhole could connect distant points in space and time, making interstellar travel more feasible. However, wormholes are still theoretical. We have yet to find concrete evidence of their existence. We haven't observed them directly, and their elusive nature continues to challenge our understanding. Even if they do exist, traversing them would present immense challenges. The energy required and the potential risks are beyond our current technological capabilities. The journey itself could be incredibly unstable and dangerous, with unknown consequences for any travelers brave enough to attempt it. Section 5. The grandfather paradox: can you change the past? The idea of time travel raises fascinating paradoxes. Perhaps the most famous is the grandfather paradox. Imagine traveling back in time and accidentally killing your grandfather before your parent is even born. If your grandfather died, you wouldn't exist. But if you don't exist, how could you have traveled back in time to kill him? This paradox highlights the potential contradictions of altering the past. Some physicists believe in a self-consistency principle. This principle suggests that even if time travel is possible, you couldn't change the past in a way that would create a paradox. Section 6. Einstein's timeless universe: past, present, and future as one. Einstein himself had profound thoughts on the nature of time. He believed that the separation of past, present, and future is an illusion. In his view, the universe exists as a single, unified space-time continuum. Imagine a vast cosmic movie reel. Every moment in time, past, present, and future, exists simultaneously on this reel. We, as observers, are like projectors, experiencing each frame one after another. This concept, while mind-boggling, suggests a timeless universe where everything that has happened is happening and will happen already exists. It challenges our everyday perception of time as linear and absolute. Section 7. Time travel in our minds: from science fiction to reality. While the practicalities of time travel remain uncertain, the concept continues to captivate our imaginations. From H.G. Wells's The Time Machine to movies like Back to the Future, time travel is a staple of science fiction. These stories allow us to explore the possibilities and consequences of venturing through time. Whether or not we ever build a time machine, Einstein's legacy lives on. His theories revolutionized our understanding of the cosmos and challenged us to rethink our place within it. Time, once a simple, unwavering concept, became a source of endless fascination and profound mystery.